So the first thing I'll introduce technically in QGIS to do this analysis is the idea of raster processing. So all last week we were looking at vector processes that are all under this vector menu item. And you might have noticed right next to it is this other menu item called raster with a lot of similar kinds of processes. And this is fundamentally the two tools or the types of files that you can work with in GIS. A vector deals with point, line, and shape data, so it's scale independent boundary data, which is really useful, as we saw last week. Raster actually deals with image data, but instead of just looking at images as a representation of color, which is a typical kind of raster image that shows color for each pixel, we're going to actually use rasters where each pixel can do its own processing. And this way we can do grid-based processing over large areas very efficiently. And the files, instead of being stored as shape files, they're actually stored as image files. So the first thing I'm going to cover very quickly is one way of using rasters, which is actually to import image data into and georeference it in GIS. And this is very useful for doing things like underlays. If you can't find the GIS data for the specific issue you're looking at, but you can find, say, a map of it, you can bring that map in as a raster image and then georeference it so you can start to digitize that information from a raster map into GIS. If I have this map of Shenzhen, but I can't find any maps dealing with urban villages, I might be able to find a map online. So I just Googled Shenzhen urban villages, found this map of all the urban villages in Shenzhen, right? So what I want to do now is import this map. I need to first geolocate it so it overlays with all my existing GIS data, and then I can actually start creating a new shapefile that geocodes or digitizes every point. It's a time-intensive process, but a lot of times that's the only way to get this information to GIS. Okay, so I have that image here. What I'm going to do is, and I have the boundary of Shenzhen here, I can use that boundary to coordinate with the boundary here and try to get them lined up. So to do that lining up, in Raster, there's a tool called Georeferencer. So I'll click that. It creates this pop-up where you can load in an image and then specify its geographic reference. Okay, so first thing I'll do is go to add a raster layer. I'm going to navigate to that image in my directory. And then I have to specify the coordinate system I want to use for that image. Typically with any kind of geographic work, unless I'm doing spatial processing, I'm going to use WGS84. Okay, so it has a preview here. This doesn't have any geographic information yet. To specify the geographic information, I basically have to relate a set of points between the image and my map. And this is really easy to do. You just click on this button here. This is add point, and we just start picking partner points between the two maps. You can pick a point on the image. Typically, we want to pick something around the boundaries of what you know. So I'll pick this point here. It'll ask you for the latitude and longitude coordinates of that point. And most times you don't know that unless you have it specified on the map itself. You can click this button that says pick from map canvas. It'll give you back to your map, and you can click the same point. So this is the point I clicked. Click it here and click OK. Now you see what happened. There's now a little dot where I clicked on the image and the dot on the map. And now those are linked. So typically, if you're working in the same projection system and you know you are, you don't need any distortions in the map. You can specify just 3 points. Any 3 points will translate both the position, rotation, and the scale of any image. If you aren't sure about what projection system you're using, you might have to distort the image a bit. And in that case, you want to select at least 4 points. And you just select more, it might specify more, but at a certain point there's constraints on the system. It won't get exactly in the same position. And we're just looking for generally in the same location. Okay, so what I'm going to do is, because I'm not sure what projection system this is, it might be warped or distorted, I'm going to pick 4 points. I'm going to pick this point down here, so this is the tip of Shenzhen. I have the location here. Click OK, see it's adding these points. I'm going to click a point out here. Import that from my canvas, click OK. So now I have 3 points. This would be enough if we were working with the same projection system, but I'm going to pick one more on the other side in case it needs to distort the map a little bit. I want to make sure that it gets as close as possible. So I'm actually going to pick a point up here and up here. Okay. So now I have those 4 points, and I can tell this plugin to distort my map and georeference it so it overlaps with my information in my map. Okay, so to do that, I just hit the run button. And it's going to ask me for some information. The first is the transformation type. So again, if you're working with the same projection system and you know for sure that you can do linear, but typically I'll pick polynomial. Polynomial is the simplest distortion model, which will warp it a little bit, but not too much to fit within those constraints. So if you're not sure, just pick polynomial, leave the rest as default, and then for output, you just have to specify a name, just like before. And it's going to create a new file, but in this case, instead of a shapefile, it's going to create a TIFF, a GeoTIFF file. GeoTIFF is the same as a normal image format. It just has information about pixels and values, but it's also going to be spatially referenced. Okay, so each pixel will have a specific place in the world in addition to a value. So I'm going to specify the file name here. Click Save. Don't worry about all this. Just leave it as default and then load in GIS when you're done. Click OK. Like always, I'm going to specify a coordinate reference frame. Right now, because I'm working on geography, I'm just working in WGS84. I'm going to leave that as a default. Click OK. And then it should appear in the window. If it doesn't, something might have gone weird with the coordinate reference frame planes like last time. And you just might have to update the reference frame here. Yeah. Okay, I think because my map was in Mercator, it projected into Mercator. So just like last week, if something doesn't quite look right, the first thing you should do is try to change the coordinate reference system, because it might create it in a different one that you actually specified. Okay, so now if I just drag that under my boundaries, you can see that's pretty good. And there's going to be areas where it's not exactly right, and you can finesse this and go back and change those points. But in this case, I might just want it to be pretty good. You can see that even the geography of the city itself is different. This is all the reclaimed area in the last few years. Okay, so that's the basic tool. Now once you save that TIFF file, it is georeferenced, so it's going to be like a GIS file. You can open it in Photoshop and look at the image file itself, but when you drag it into GIS, it will have a georeference to it. And you can see how it's twisted a little bit and distorted to get it in the right position. All right, so that's the georeferencer tool. That's just a really useful tool that will get you started thinking about doing raster-based analysis. That's the kind of first way to use rasters in GIS, is just to bring in underlay files so you can digitize information.